Contextual embedding refers to a type of word embedding that takes into account the context in which a word appears in a sentence or document. Unlike traditional word embeddings, which assign a fixed representation to each word regardless of context, contextual embeddings generate different embeddings for the same word based on its surrounding words in a given sentence or document. Contextual embeddings are obtained from models trained using unsupervised learning, such as BERT and GPT. These models are trained on large amounts of text data and can generate embeddings that capture the meaning of a word based on its context. Contextual embeddings are an advancement in word embeddings that capture the contextual information of words. Unlike traditional static word embeddings like word2vec or glove, which assign a fixed vector representation to each word, contextual embeddings generate word representations that are dependent on the context in which the word appears. For example, we have two sentences, Bunny loves artificial intelligence and Bunny loves machine learning. Loves exists in both sentences, but the embedding for this word can be different. One of the major reasons is that the same word may have different meanings in different sentences. For example, apple can refer to one of the fruits, while it can also refer to the company too. One of the popular training objectives for learning contextual embedding is to train a model on large amounts of text data using a masked language modeling objective. During training, the model learns to predict the masked or missing words within a sentence. By doing so, it develops an understanding of the context and relationships between words. Every time, the preprocessor will mask some of the tokens and inputs and let the model predict the masked token so that model learns the context and relationship between words. It is similar to filling in the blank exercise, which we did in elementary. Another popular training objective is language modeling. For example, GPT model learns to predict the next word in a sequence given the previous words. By training on a large corpus of text, GPT learns to capture the semantic and syntactic properties of words and their relationships within the text. This time, the model will be based on previous words, which may include the previous predicted word to predict next words. Contextual embeddings go beyond traditional static word embeddings by capturing the contextual information of words. They are trained using large-scale language models that learn to predict words based on their surrounding context. These embeddings provide a more nuanced representation of words, allowing models to understand and generate text with a better understanding of context.